Here we've got a function machine, as with the last lesson, and we've got an input, output, and the function here is defined as times 2 at 3. So if we were going to find the function when the input was x, that would be times 2 is 2x plus 3. So f of x will be 2x plus 3. Now we're going to look at the domain and the range of this function now. So the domain is defined as the set of values that can be put into it. So here there is no restriction on the values that can be put into x. It could be fractional, it could be infinitely large, it could be massive and negative. So you'd say that the domain here, we can use all values of x. So now let's have a look at the range. Let's say we used all of those values of x. You should be able to see that there's absolutely no restriction either on the values that would come out. So we could also say that we can have all values of f of x that will come out of the function. So find the range of f of x for each of the following. So we've got a function of x here, which is 3x plus 2, and this time we've been given a domain. So we've got imposed restrictions on the values of x that we can put in. So x can be any number bigger than 5. So if I put 5 in, I'd have 3 times 5, which is 15, plus 2 is 17. So it therefore follows that f of x could be any number bigger than 17. Because I'm allowed to put in any number bigger than 5. And if 5 gives me 17, then f of x could be any number that's bigger than 17. With the next one, we've got restrictions at both ends here. So x could be anything less than 4, but also it's going to be bigger than 1. So if I put these two in, so if I put 1 in, I'd have 10 minus 2 times 1, which would be 8. And I'd also have, putting 4 in, 2 times 4 is 8, 10 take away 8 gives me 2. So those are the limits there. So I could say that given the input of x being less than 4 or bigger than 1, the function of x will give us some number always less than 8 but bigger than 2. Again, we've got another example here. So x can be any number less than or equal to 2, but it'll also be bigger than or equal to minus 3. So let's use these two limits first of all. So we'll have minus 3 squared, which is 9, plus 2 is 11. And then 2 squared is 4, plus 4 is 6. So that tells us for certain that the upper limit is 11, because I'm never going to get a bigger number than 11 out of that in the range minus 3 to 2. But the 6 actually doesn't tell me anything here, because I could get easily a number lower than 6 out of this because of the squared term I've got involved here. So x equals 0 also falls within this range, and if I put in 0 here, I'd have 0 squared plus 2, which gives me 2. So 2 is the smallest number that I can get out of this, because of course I'm never going to get a negative out when I square the number. So here our function of x will always give us and some output which is less than or equal to 11, but it will also always be bigger than or equal to 2. Find the domain and range of the function of x for each of the following. So here we'll look first of all at the domains. Now be careful when dividing, because obviously we can't divide by 0. So the only restriction we've got here is that x could take all real values except for minus 3, because if I had minus 3 plus 3 on the bottom, it would give me 0. So, and that's kind of like solving the equation x plus 3 equals 0. So x equals minus 3, and that's the value that we can't be using. So x for all real values except for minus 3. And you could also write that as not equal to minus 3. So now let's have a look at the range. range is not so easy to spot actually here. So obviously I can't put -3 in, but there's no restriction elsewhere in terms of putting x in, so there's also no restriction on what comes out, other than the fact that 1 divided by something will never ever give me the answer of 0. So here we'll say that f of x can take all real values, except it won't be taking 0. Domain of this one, so values that I can put in are restricted here. I can put any fractional number, any hugely positive or hugely negative number in here, and there's no restrictions at all, so this is all real values can be put into here. I can square any number with no problems at all. For the range, I'm going to have a look at what can be taken out, and there is restrictions here because I'm squaring something, which tells me that I'm not going to be ending up with a negative number. So just when we were squaring something before, we should have realized that the smallest number that we can get will be 0 when I square this. So 0 squared would give me 0, but because I've got that +3 on the end, that tells me that I'm always going to end up with an absolute minimum of 3. So here we'll say that the f of x is always going to be bigger than or equal to 3, and we need the or equal to because obviously if this had a value of 0, then we would still have exactly 3. So f of x could be anything bigger than or equal to 3. So here we've got a similar kind of question. We've got a function of x, but here we've got a square root in the function. So if we are going to think about the domain, we need to think about the fact that you can only square roots and positive numbers. So this can't, in this term here in effect, the x minus 3, can't give us a negative value. So x minus 3 has to be bigger than or equal to 0, in which case x has to be bigger than or equal to 3. So that's the domain. Because as long as this has got a positive answer, then we'll be able to square root it, and that's not a problem. So the range, given that that's the domain, well, if 3 did go into there, we'd have 0, and this whole thing, square root of 0 being 0, plus 5. The range is going to be an absolute minimum of 5. So we'd say that the f of x is always going to be bigger than or equal to 5. Find the domain for this one. Again, we've got a division problem here, so we know that this on the bottom can't be equal to 0. So if we just put it equal to 0 and then we can solve it, we'd have 2x equals 1, so x must equal a half. So that's the value that we can't use, that x equals a half. So we can say that x could be all values. Sometimes I write real values, sometimes I don't. You need to be familiar with that. I'm referring to real values here when I say all values. And yeah, however, it can't be except for a half, or x not equal a half. So the range, again, similar to the question before that we had with the division really, 4 divided by something will never give me an answer of 0. So x can be all values except for 0.